Okay, this is the third video of my canonical correlation series. Um, I'm going to warn you that this video actually gets pretty hairy. Canonical correlation by itself, when you're just reading the literature, is already tough. But the more advanced stuff that you do is even tougher. So let me give you a little bit of a recap. You use the statistical multivariate analysis of a canonical correlation, or CCA, in order to determine the relationship between two sets of variables, not just a variable and a collection of other variables like a multiple regression, but two sets of variables. So you've got a bunch of variables that talk to each other, they're correlated with each other, and they're going to have a relationship to another bunch of variables talking to each other. There are all kinds of different relationships that we went over in the first couple of videos, and all kinds of coefficients that come out of a canonical correlation analysis. By the way, when I run CCA, I use R to do it. But you can use, SPSS or whatever. Anyway, but the point is that whatever statistical package you're using is going to produce all these different measures that come with your CCA. We can use a CCA to compare sets to sets, and we found that you could report it by showing not only your canonical functions involved, but the actual canonical correlation, your F statistic, your p-value, and your multivariate significance tests like p-Lie trace and Wilks lambda. Not all of your functions are going to be significant, and remember there are as many functions as there are the smaller number of variables in a set. A set of 10 versus a set of 5 will produce 5 canonical functions. Okay, you can use redundancy analysis to show whether uh, A's contribution to the relationship is higher given B's contribution, or B's contribution to the relationship is higher given A's contribution. That's redundancy analysis, and we get back to redundancy analysis in this video. Okay, so let's say you've run your CCA and you've found, how's my time here? You have found that there is a significant relationship, right? It's kind of like saying, does Team A relate to Team B on this field as far as how they're interacting with each other? Yes, there is. What if I compare them in the preseason versus the postseason? Okay, well now you want to partition your sets and rerun the canonical correlation, and this is where we get into redundancy analysis. So in my particular study, which I'm using to walk you through this video, I reran my CCA on 100 males only versus 193 females only to see if there was a difference in the CCA results for sex. And when I ran that, I looked at the redundancy in this indexes, and it turns out that my predictor versus my criterions were produced different redundancy indexes which had consistent kind of highs and lows across the two sets. In other words, the male redundancy index was higher in this set than this one, and it was also higher in this set versus this one. So there was a consistent gap in the redundancy indexes, and that tells you that these groups were not equally stable across the canonical correlation. This is always influenced by sample size, and there are all kinds of rules for how much you sample. But anyway, um, the point is that when you look at the redundancy indexes, you can see if these numbers are similar, then maybe there's not a difference between the two groups in the CCA. But these aren't similar. This is a pretty sizable gap. Look at that. I mean, 74% difference. This redundancy index is in the area of twice this redundancy index. Same thing here. Males and females are really highly likely to be different on this particular comparison. But that's all that a redundancy index tells you. It doesn't tell you anything more. Um, you have to actually run other results in order to see how they differ. So we're saying, based on the eyeball test with redundancy indexes, we have differences in the results here. But let's look at more detail. How do we test the differences between two families of results in a CCA? Okay. Well, what you can do is a kind of post-hoc testing is do something like maximum likelihood factor analysis to see what factors are influencing the male set versus the factors influencing the female set. and see what factors pop out and what they load on. And that's essentially what we're going to do. You can also use a backward stepwise logistic regression among all of the variables involved in this set combined with this other set in order to see when you put in these factors where the changes in the relationship actually occur. I'll walk you through that now. Okay, so first of all, let's see how many dimensions are involved in the differences between the males and the females. Okay, so I use maximum likelihood factor analysis, which you can use, and that's more exploratory. Um, and it suggests that both the male data and the female data loaded on 5 dimensions. So you use this factor analysis to say, okay, how many factors are influencing the male results? And you'll look at your chi-squares in your RMSEA, and both of them suggest about 6 dimensions. You're looking for non-significant chi-squares for this particular result. And when I report these, I basically say in the 5 retained factors case and in the 6 retained factors case, I get differences among male or female. You can talk to whoever's helping you with your research in order to get more into it. I don't want to dwell on it too much. But the point is that with our non-significant chi-squareds here, the 6-factor thing works better. Okay? These are the results for the EFA, the exploratory factor analysis on the female structure loadings. And basically, I've got this factor 1, which loads on dominance, arrogance, and coldness. In other words, this factor, when you look at its eigenvalue here, again, this all comes out in the interpretation, so don't worry about what eigenvalues are and stuff. But this factor is again, you have to use your statistical intuition for this thing to say, okay, what do anti-humaneness, with that negative there, internally competitiveness, dominance, arrogance, and coldness have in common? I called that factor assuredness. And then I looked at what does aloofness, submissiveness, unassumingness, and warmth all have? What do those all have in common? And I called that slightly communal submission. And then you're basically looking at what families of variables, of all of your variables from your 2 sets combined, have these factors loading on them, and then you're coming up with your own summary of what those factors involved are. And so these are the female factors right here, and these are the male factors. The loadings are going to be different. Well, and for your study, they might be different, they might not be different. But you can see some of the dimensions that came out in this analysis. The female factors included things like assuredness, slightly communal submission, slightly agentic warmth, virtue and aloofness. The male factors had things like detachment and heroism. Where does heroism come from? Self-sacrificing autonomy. That's what I called it, right? And again, this comes out of the statistics, but your naming of the statistical classes of the factors involved basically show you this. Now, the factors go in order of decreasing importance, kind of, and that's going to produce a neat little chart, which I'll show you shortly. But let's just summarize it here. The male factor heroism is similar to factor 5 virtue for females, but humaneness isn't necessary. And these were what you get from comparing this table to this table. Okay, so this basically tells us what the difference between our 2 sets were. I looked at the factor loadings for one partition, the factor loadings for another partition, and then I'm looking at what was in one and what wasn't in the other. There's another thing in here, but I'm not going to go over all that. Just know that you're comparing your factors. Now, we've got our factors involved, and we say, okay, virtue, aloofness, whatever, but if you go back in here, it's not like this factor here, which we called assuredness, tells you whether arrogance is the key player or coldness is the key player. This statistical test doesn't do that. So you have to have another statistical test to say, okay, well, look, across the board, between female versus male, which of the variables are really making the difference. And for that, you use a backward stepwise logistic regression. When I do that, I found that status consciousness, self-sacrificing arrogance, submissiveness, unassuming,ness, and warmth all contributed to as variables to the difference in the game between these two partitions of teams. So it's kind of like saying, if we wrap up times here, it's kind of like saying, back to the analogy of the football teams, when you have Team A versus Team B in the preseason versus the postseason, who's making the difference? And you say, it's the running back, or something like that. Here, self-sacrifice, arrogance, and submissiveness scores tend to make for more male training. Status consciousness, unassumingness, and warmth tend to make for more female training. And actually, if you're familiar with these constructs that I'm using, you know that this is consistent with the literature. When we look at interpersonal relationships, males tend to be slightly more trained on dominance, just slightly, and females tend to be just slightly more trained on warmth and communion, talking to each other and stuff, and males have more of that assertive thing as part of their social training. May not be their individual behavior, but it's part of their social training at least. Okay, this is just it's just a graph. Don't worry about it. It actually doesn't show everything because there are different factors involved. What I really wanted to show you is, oh, and by the way, you can do bivariate correlations only on males and only on females, and you can see where the weightings are and tell based on the factors that were pulled out of the stepwise logistic regression that the females and the males were different. Males tended to divorce more of the factors that we're looking at. What I really wanted to show you was this. So just for the first three major factors here, factor one is going to be the most, I'm not going to say the most significant, but yeah, it is. But factor one is the most significant, then factor two, then factor three. And basically, males are trained to go this way along factor one, then this way along factor two, then this way along factor three. Females are trained to do that too, but take a look at what variables actually were involved in these. Males are trained in this dimension of like anti-self-sacrifice, more status consciousness, and then autonomy gets prioritized, and then this whole internally competitiveness, humaneness axis comes in. It's kind of a third thing. With females, it is starting at self-sacrifice, and it looks like bureaucratic, and then factor two, you see this, trains in the humane. That's going to be humane and the anti-internally competitiveness, and that's going to be a second kind of priority. And then the third one is autonomy. Let me try that one more time. Males look at status first, or they're trained to look at status first. Autonomy second, humaneness third. Females are trained to look, at least from this sample, to look at the more face-saving dimension and bureaucratic dimension first, then humaneness second, and then autonomy third. And a big difference is in the order in which we're trained to prioritize humane treatment of other people versus autonomy. I do want to have a brief comment on ipsitizing. Sometimes when you're working with circular statistics, the way I was for this study, there's an element of normalizing within the group before you do all this analysis versus not normalizing within the group. Ipsitizing is where you normalize within the group. The only thing about ipsitizing which you have to watch when you're dealing with intercorrelated sets is that when you ipsitize, you're setting an internal baseline. So if I have measures like brashness or neuroticism or extroversion or outgoingness or whatever, extroversion and outgoingness, if I have measures like that and I normalize across those variables within myself, you can imagine how that's going to tell me how I weight those factors internally. If I don't ipsotize, then I can compare my weightings of those factors to your weightings of those factors. And so you have to watch whether you ipsotize these things, because if you normalize within the group, then you're basically setting the group's standards as the baseline. And when you don't normalize, you're setting the across party comparisons as the baseline. And depending on what your aim is, that's definitely going to affect your results. It affected mine in this study. When you run the CCA on ipsotized versus non-ipsotized data, you get significant results, and it has implications for factors which are internally enforced versus externally enforced. But that's another methodology question.